In this video, we're going to learn about line symmetry, which is also called reflectional symmetry. So basically what this means is if you're carrying a shape onto itself using a reflection over a line. So if you imagine this figure below, this has vertical line symmetry, meaning if I imagine folding this shape along this line, what's going to happen is this point right here will match up to this purple point. This red point, let me make it green, will match up to this green point. The blue will match up to the blue if you reflect over that line. And these red points are just going to stay in place because they're on the line. So when you look at this figure overall, we say it has vertical line symmetry because those match up. Now, if you imagine drawing a horizontal line through it, so let me do it, but then I'm going to erase it. If I draw a horizontal line through it and you imagine folding along that, this purple point would end up somewhere over here, which means it's not going to end up on this point down below. So we would say it doesn't have horizontal line symmetry. So this is not one of the lines of symmetry. So that's kind of the idea when we talk about symmetry among a line or amongst a line, is that it has to match up, or it has to be a mirror image on the other side of the line. So now below, this is kind of just like a special case that only works for regular polygons. So I'm going to just go ahead and I'm going to highlight this statement here that says the maximum lines of symmetry that a polygon can have are equal to its number of sides. And then if you just recall that a regular polygon from middle school means that all sides and all angles are congruent. So for regular polygons, like an equilateral triangle, that's a regular polygon because all angles are equal and all sides are equal. A square, all four sides are equal, all four angles are equal. So if we look at these examples, see how this octagon, it has 8 lines of symmetry because it's regular. And so that means 8 sides, 8 lines of symmetry. So if you look, we have lines of symmetry that are going through the different vertices of the shape, as well as bisecting one of the segments. So those are our different lines of symmetry. Still applies to this regular pentagon, but pentagon has 5 sides, so 5 lines of symmetry. So if you imagine folding them along any of these lines, you're going to see that the figure matches up, or it maps onto itself, which means that it does have line symmetry using those lines.